Now I want to integrate natural exponential functions. The integral of e to the x dx is e to the x plus c. The integral of e to the u du, provided we have the derivative of our equation in u, is e to the u plus c. Let's see if we can apply this formula. In order to find the integral of e to the 9x dx, we begin by letting u equal 9x, du equals 9 dx. So if we solve this for dx, we get du divided by 9. So now the dx here is going to be replaced with du on the inside and 9 on the outside in the denominator. 9x is replaced by u, the integral of e to the u, so we have 1/9 e to the u. What is u? 9x plus c. Suppose we had a little messier integral to find. Here, integral of e to the 1 over x squared over x cubed. We can rewrite x squared in the denominator as x to the negative 2. So we now have the integral of e to the x to the negative 2 power over x cubed dx. Let's let u equal x to the negative 2. du equals negative 2 x to the negative 3 dx. But now notice we have an x dx divided by x cubed, which is x to the negative 3 dx. So if we solve for that, we get du over negative 2. So we can rewrite this as du negative 2 in the denominator, e to the u, which gives us e to the u, which is now e to the negative 2x divided by negative 2 plus c. Suppose instead of monomials we have a binomial divided by a monomial. What we can do here, and this is only valid if this is a monomial in the denominator, we can break it up into two nice parts. 5 over e to the 2x minus the integral of e to the x over e to the 2x dx. Now e to the 2x in the denominator is the same as e to the negative 2x in the numerator. Minus, and if we cancel, and we're left with e to the negative x dx. So this gives us 5. Now if we let u equal negative 2x, and we integrate, we get e to the negative 2x, but we need a negative 2 in the denominator. Minus the integral of e to the negative x is e to the negative x divided by negative 1. So we wind up with negative 5/2 e to the negative 2x plus e to the negative x plus c. Suppose we're interested in the area under the curve from 1 to 3 of the equation e to the negative 6x. We can let u equal negative 6x, du equals negative 6 dx, and dx would equal du divided by negative 6. So that means we could rewrite the integral as the integral, negative 6 out in front, du e to the u, x goes from 1 to 3, which would be e, and u is negative 6x to the negative 6x divided by negative 6, x goes from 1 to 3. We could use change of variable here, but let's just work it directly through. We replace x with 3, so we have e to the negative 18th divided by negative 6. Subtract, let's replace x with 1, e to the negative 6 divided by negative 6, which would give us, as a final answer, 0.00041666.